Please welcome at Hightower.
Very good. Thank you. I have a lot to cover, so what I skip over today will be, we're recording it so you can look at their website and review later on. Also, I'll put the slides up on my LinkedIn profile, so it's easy to find, Ed Hightower on LinkedIn. So do take a look at that and follow through on the details of what's going on. Today I'm going to cover a little bit about what the history of IoT is, how it got to where it is now. I break it down into three areas: devices, wireless, connectivity, and the back end, which is very complex and has lots of issues to it. But I'm not going to go into that today. I'm going to talk about the connectivity part, particularly that's going to enable massive adoption of the Internet of Things. And that's the low-power WAN technologies that are coming on board. And then how that applies to smart cities and smart health and whatnot. Internet is awesome. Google is great. You get lots of great information if you filter it and confirm that the information is good. The first example of machine-to-machine communications was the telegraph. So you think about it, you push a button here, and miles away sometimes, something happens at the other end, and vice versa. You're listening, and you hear that other. So remote monitoring and control capability. So that was the first thing. And Tesla's awesome. He predicted where we are right now. Device in your pocket, your smartphone, whatever, that can access information in the world and control objects anywhere in the world if you needed to or want to. So in the past, machine-to-machine was a vertical type of operation. You had these individual domains that you were collecting information for. You weren't necessarily sharing that information. That was more or less called machine-to-machine, and it was called also by other names: telemetry, SCADA, telematics, sensor networks. And you use wireline and various types of wireless technologies to be able to get that information from remote locations back to your computer systems. And as we've seen earlier, the definition of machine or Internet of Things is the intelligent connectivity of objects in the world, and then allowing that information to be used to somehow improve the quality of our life and make things more efficient. It's going to be the nervous system of our planet. We're going to be able to monitor and control things that were never economically feasible in the past. Sensor cost, connectivity cost, computer cost is going down, and the power is going up. So we're going to be able to do things we never were possible to do in the past. This is going to be a game changer. It's going to be an inflection point. Andy Groves talked about it. There's been several in our lifetimes, in my lifetime anyway. Jack Kilby here at TI created the integrated circuit. Our whole electronics business is built on his invention. And in '84, the Bell monopoly was broken up. That created incredible innovation in the industry. In the early '80s was the personal computer. The '90s was the Internet of Things, or Internet. And then in 2007, Steve Jobs changed the world by putting a supercomputer in our pocket called the iPhone. This inflection point will dwarf anything that's happened before. We're going to have 50 billion devices online in the next 5 to 10 years. Depends on who you talk to as to how quickly this adoption is going to take place. But it's going to be massive, and it's going to change our world in ways that we have no way of understanding at this moment. It's very complex. The ecosystem is very rich, very diverse. The architectures are very diverse as well, and there's lots of different ways of doing this. No standards out there. So it's a wild west. 3 parts to it. I break it down. So the devices out in the field, then the connectivity, whatever it needs to be, and then the back end, which is a very rich environment in itself with computer systems and cloud and analytics and tools and applications and things that are back there. I'm not going to try to get into that because that could be a whole day discussion. But I'm a wireless guy, so there are many ways that in the past remote objects have been connected. Wireline, and then the various wireless technologies: microwave, radio, cellular, Wi-Fi, and satellite. Cellular, let me back up. Cellular has been out there for a long time, but it's expensive. And Wi-Fi is short-range, Bluetooth and with Zigbee and mesh and whatnot. Short range. You try to put a large area together and manage it, it's a real complex situation. So it's not really good for a lot of applications of the Internet of Things. Private radio and microwave are not ubiquitous, and satellite has great coverage, but it's still pretty expensive. That brings me to low-power wide area networks, LPWANs. This is something I have heard about and known a little bit. I started hearing about it about 4 or 5 years ago, and I was invited to speak at IEEE about it at one time, and that's put me on the path of keeping up with all the different versions and protocols and approaches to low-power wide area networks. So what are they? Low power wide area networks are long-range wireless systems, but they're low power. By being low power, they have low battery consumption, and they allow the battery to last a long time. You also use other techniques like putting the device at the remote site to sleep as often and as long as possible, and don't have you wake up and talk for minimal amounts of time and then go back to sleep. It's also, a low power WAN needs to have a low cost infrastructure. Cellular is based on providing communications to our smartphones, so their network is extremely expensive. We're trying to create with the low power WANs low cost infrastructure which that cost savings can be passed on to the user. The other is that it needs to be scalable because we're going to have 50 billion devices connected here in the near future, so it's got to be able to handle more and more and more devices in a cell site. And it needs to be support mobility. So if a device is moved from a city to another city, another state, or another country, it needs to be able to register into a network there and be able to be used as well. And in some cases, some low power WAN systems will actually support moving objects, so your supply chain and vehicles in the field. But the thing that is not on here, it talks about, these low power WAN systems are good for applications where latency is tolerable. So if you're talking about a real-time system that needs critical information quickly, this is not what you want to go with. You want to go with something like 5G, where you've got a big battery or you're on the grid, and you have instantaneous communications that's going to be needed in a connected car. John Lindsay can talk to you about that, because that's something he's working on. So did I just kill it? So there we go. All right, so cellular will be around in a lot of applications, but it will have, it's the green or the blue, if you want to call it, some minimal applications according to certain analysts that have looked at this. Low power WANs, Wi-Fi, Bluetooth, mesh, whatnot, they'll have applications as well. But about 60 to 80, depends on who you talk to, 60 to 80% of applications after massive adoption of IoT is going to be supported by low power wide area networks. And that's because 86% of all the IoT applications that are going to be used need less than 3 megabytes of data per month. 3 megabytes. These systems are very efficient with the communication, not a lot of overhead. So what you're getting is a lot of information being transferred that's useful, not overhead, setting up a call, that kind of thing. 76%, 76% need 1 megabyte or less. So there's going to be a lot of demand for low power WANs. So there's several different examples of low power WANs. Sigfox has been out there for many years. They did a great job. They took a very simplistic approach to low power WANs, marketed the heck out of it, and have over $300 million to work with now to put networks in. They've done a great job at marketing, but their network and their approach is first generation. So, and it's very minimal in the amount of data it can carry. And it's very limited on its return channel. So some people say it's not two-way, some people say it is. It depends on the rules of the country you're in. But it's very minimalistic type of application. More details, if you want to go to my website and to the LinkedIn profile, get more details about it. There's two kinds of approaches right now for the most part. The center one, the spike, that's a narrowband or an ultra narrowband, which Sigfox is ultra narrowband, and weightless N is a narrowband. So the idea is you're putting a lot of your energy in the spike, narrow part of the spectrum, and you're punching through the interference, and you're getting the best range you can by putting your energy in one area of the spectrum. The bell curve that we're seeing out there, that's the other approach. It's spread spectrum. So LoRa and Ingenuity use spread spectrum, and it's below the noise floor, so it actually looks like noise. We did that to the Soviets back during the Cold War. Qualcomm did this, and they never could find it. We encode the signal at the one end that we transmit from, and we decode it the other end, and nobody realizes that it's actually being transmitted. It looks like noise. So the two different approaches to putting in low power WAN systems. They're both very low power in their usage. So LoRa does that. They do the spread spectrum. They use chirp technology or chirp approach. It's not a real robust and powerful approach, but they did a great job. They ran real quick and created something and started marketing. So they and Sigfox have a head start. They're doing a good job of getting customers and getting systems out there. Their business model is to create, for the most part, communities that are using it, and then connect the communities. There are some companies like Senet, S-E-N-E-T, that are using this technology to create public networks. So we'll have to see how this goes out. All of these approaches are going to be proven or fail in the marketplace, depending on how well they work, as we build up the loading on the networks. More details on that. There are some deficiencies. So in LoRa, the physical layer, the chips that are created, is owned by the IP, intellectual property is owned by Symtec. Anybody else that wants to produce it has to have a license from it. But the MAC layer, the stack above that that controls the physical layer, is open source right now. It still has some issues. It doesn't solve the problems that the physical layer has. These guys, SymphonyLink, part of the product of Link Labs, tries to address some of that and improve the capabilities of the physical layer by adding more capabilities at the MAC layer above. And we'll see how this works out. It's proprietary, so you have proprietary physical and proprietary stack if you go this route. Weightless in is one of three protocols that are open source from Weightless SIG out of the UK. Weightless W is for white space, TV white space. Came out about 4 years ago. It's the first one I read about. It's been put on the shelf because the only two countries that allow it are UK and US. But other countries are real slow in adopting it. So they put it on the shelf. Weightless in came on. It's very similar to Sigfox. Very short messages, very limited in its ability to transmit. It has a limited response capability. Each of these have their niche. And this is probably going to be a very good one for parking, smart parking. And in fact, there's a network here at UTD right now on the Fish Building. I forget what the name of it is, but you know what I'm talking about. So they're doing testing and showing how it can be used. This is the one I'm excited about. It just got released late last year. Weightless P. P is for performance. It's one of the weightless standards. It is powerful, robust. It comes from 7 years of study at the British FCC, which they call Ofcom, and then technology was donated, the IP, by a company out of Taiwan that has used it for industrial type of applications, and they combine the resources and the research for those two things to come up with Weightless P. When you start looking at, it's a fully two-way system, highly adaptable, high data rate. And it's open source, so anybody can start building on it and not have to do licensing and whatnot. The first guys to do it are UBIK, U-B-I-I-K, and they'll be actually sending out hardware, base stations, radio modules, and sensors in June of this year. So watch them, because I think this is going to be something that could be used to build communities and possibly used to put in public networks in the future. Ingenuity. Very interesting company. They have been around since 2008 as ONRAMP before. There actually, some guys came out of Qualcomm using the CDMA technology, modifying it instead of going smartphones with high data rates. They're going to short messages, adaptable data rates, but billions of messages that they can handle with their approach. Again, we'll have to see how all this works. They've changed their business model from putting in private networks to putting in public networks in 120 cities by the end of this year. I wish them luck. It's going to be a big challenge. If they succeed in what they're trying to do, they could be a force to be contended with. But the big gorilla in the room is the cellular guys. They've got 5G for their smartphones. Another part of their efforts, they rushed through this standard called narrowband IoT. And it was adopted by the 3GPP community in June of this year. However, because they ran through it real quick, they don't have a lot of research and trials behind the effort. It has many holes. So if you talk to some people, it has 7 different deficiencies in the way that they are going to implement their narrowband IoT. It actually is part of the LTE signal, or it could be in the guard band. You will never put this in a rural area. You can only put it where you can justify putting up an LTE tower and support smartphones or whatever else in that area. And if you do that, then you can put NB-IoT, and it's a part of that radio signal. But these guys have worldwide coverage, 800 entities involved in the 3GPP, billions of dollars behind it. They will figure out a way to make it work. But it may take them 3 to 5 years before they actually fill the holes and solve the problems. So, that brings me to smart cities. Got 5. Okay, good, perfect. All right, so as we know from smart cities, it's the use of information technology and communication technologies, and now the Internet of Things, to be able to create smart cities. So they call this data that we're collecting urban informatics. And they're using various technologies, communication technologies and device technologies and back-end technologies to be able to get a picture of what's going on inside of our communities. And by doing that, we're going to be able to make our cities more efficient, be healthier, and be a better place for us to live, and draw, if the cities do it right, they're going to draw people to them. If they do it wrong, people are going to get away and go find someplace else to live that's safer and a better place to live. Two of the key areas that they focus on is transportation and energy. How do you produce it, how do you transmit it, and how do you use it in the best, most efficient? So, sometimes these applications are going to be critical, so they're going to need real-time communication. So low power WANs is not necessarily the place to be, the technology to use. But if you have facilities like schools and libraries and things, you want to just make sure that if somebody breaks in, you want to know about it, but you don't need to know real time. You just need to know about it in a few seconds that something's going on. Low powers will be good for that. Low power WANs will be good for that. Street lights, if we change street lights out to LEDs and control them with some sort of low power WAN system, you save 75% of the cost of running a normal lighting system out there. Immediate payback on that kind of system. Then you got transportation systems and parking and whatnot, hospital power plants. Water supply systems and waste management would be excellent applications for low power WANs. Not critical, we can wait a few seconds to get information, but we just need to make sure that we get it reliably. Of course, there's other applications, law enforcement and whatnot. These are the 5 cities that are considered the smartest cities in the world. Singapore just won the first place. Barcelona has been #1 for many years before, and now they just took over. I would love to go there. It's beautiful. So Singapore, they've made a major commitment. They're called a smart nation. Island, and that's what the city and the nation is the same. They've made a major commitment to IoT, to use it to try things, to put in systems and see what happens. But one of the things they really focused on recently in the last year or so is their transportation system. They have one of the best managed transportation systems in the world. And that's the reason why they became #1. But they have so many other things they're doing with Internet of Things. So we need to watch them. We're going to learn from these guys. All these cities are great to go and look and see what kind of activities they're doing and what's going to work out for them. We're doing our own thing here in Dallas called the Dallas Innovation Alliance and the West End. It's a living lab. It's going to be part of what Dallas looks at, sees what the private-public version is doing, and then they'll adopt things. So, Barcelona, beautiful place. They have lots of different applications for IoT. So their traffic management is okay, but it wasn't as good as Singapore. But smart parking keeps coming up in all of these cities. And smart street lighting, 2 key areas that quickly could be great wins for them. And then they're big on sustainable and environmentally reasonable applications, or taking care of the environment. London, these guys got lots of tech. They are really encouraging entrepreneurs to come up with ideas. So they have many different entities and institutions there that are helping the entrepreneurs figure out how to use technology in general, the IoT in particular, and low power WANs in a lot of cases, to come up with solutions. And of course, you see smart parking. They're just not focused on energy efficient renewables, so that's why they're down the list on 3. A couple more, I'm done. San Francisco. Boy, I'd love to go there. This is great. One of the new ones. Great. They are a victim of the success of the Silicon Valley area. They're just north there, and they have had a tremendous influx of people over the last 10 years. So their traffic is horrible. They're behind the curve. So they are trying to implement lots of IoT applications to help their public roads and their public transport, our private car transportation, but their public transportation system also, they're putting a lot of IoT and IT type of services in place to help them improve those things. And of course, smart parking comes up again. They're very big in LEED, certified LEED buildings, which are very highly efficient buildings. Internet of Things, smart buildings play a big part in what they're going to be doing in the future. Last one, Oslo. I got to go to Norway before. Go in the summer, it's beautiful. Don't go in the winter. Not a place to be. My engineer went, he wasn't happy. All right, I'm out. But Oslo, same kind of deal. They're very big on health and other people. So the things that Oslo's doing, telehealth, remote monitoring of patients and whatnot, personal emergency response systems could be great for low power WAN systems, and tracking elderly and dementia patients and assets and whatnot. Low power WANs would be a great fit for that. I'm done. Any questions? There's lots of resources out there, so if you go look at this in detail, then you can go to these sites and get more information. I'm just planting the seed, so go study. Amazing what's going to happen in the next 5 years. Yeah,
So are they using any of these technologies in Dallas Innovation Alliance?
they're using AT&T, so probably NB-IoT, but I don't know the details. I've been focused elsewhere, but I'm going to get involved with DIA. There is a website. Go to this website for sure. I didn't put it up here, unfortunately. Do a Google search, IoT Texas Meetup. IoT Texas Meetup. If you do a Google search for that, it lists up. There's 6 of us as administrators, and we put events up there that are in the IoT arena in the Dallas-Fort Worth area. And right now there's 22 different listings up there. Some have already happened, but some are coming up here shortly. DIA has Earth Day coming up next week. 2-day event. If you can go to it, it'll be fascinating to see what they're involved in and what they're going to be doing. But there's other events also on that. Every few days, we get requests to put something up there. So there's 6 of us, we got lots of input. So go to it, IoT Texas Meetup. Yes?
So all these cities have smart parking, right? Smart parking in all the top 5 cities. What constitutes smart parking?
So smart.
At the DFW, we know there are these sensors say which parking spot is open. And so what else?
So smart parking in this context is you're putting a sensor in each of the parking spots, and this is very simplistic. Why? That is why N-Wave is such a great application for it. They don't need a lot of data, just something there or something not there. That's what it does. Their sensor senses a metal object above them and sends a bit. There's somebody here. When somebody leaves, it sends a different bit, and they know that it's open. And so all this is then controlled by on the back end, and your lights are put up there, or your information is sent to your smartphone. There's different ways to convey the information that sensor is picking up. Good question. Yes?
May I know how about the scope of bringing up low power wide area networks with the help of renewable energy harvesting mechanisms like solar energy panels like over the low power wide area network applications?
So I think I heard you say, you're talking about harvesting, energy harvesting?
Yeah.
Oh yeah, so that's going to be one of the big things. A lot of these low power WAN systems, because of the low usage of energy to transmit, I'm out of time, last for 10 years or more. But if we can start harvesting, they can last for as long as the equipment still continues. And so there's a big push to understand energy harvesting and how it could be applied to low power WAN devices. It's a great thing to be looking at. If you guys can come up with ways to do that, there's lots of technologies out there that are being looked at. If they can be commercialized, then it opens up a whole new world of sensors and their impact. There's a lot of places you put these sensors. You don't want to go back there. It is ugly, it's horrible, it's a nasty environment, and it's tough to get to. You just love to put that there and forget it until it breaks 30 years from now. Thanks, guys.
Thank you, Anne, for your high power, high energy presentation.
I love this stuff.